Okay, here's another video for your exam review, and this was quite a question on your acid-base test. Number 8. So, you have a titration with a weak base and a strong acid. So, let's just review a tiny bit of basic chemistry. So, remember that if you have a strong acid or base, remember that they dissociate completely. Okay, very important. Okay, so they don't have a conjugate. But anything weak, remember, does dissociate into just a tiny bit. It dissociates just a tiny bit. And so you do have a conjugate. In fact, quite a bit of conjugate present. Okay, so in number 8, let me get rid of that. Okay, so in number 8, we have the weak base, and let's just say that it's something like ammonia. Okay, ammonia is a weak base. Why is it a weak base? Because it's not strong. So there's a list of strong acids and strong bases. So if they're not in those lists, they're automatically weak. So let's think about what that dissociates into. So if we put it in water, you can't have an acid or base without water. And so if this is the base, then that makes this the acid. And the conjugate then is a conjugate acid of that, which would have another hydrogen ion, okay? So that means you're putting this and this together, and that would be the ammonium ion, okay? And then you would have the conjugate base of water, okay? So maybe that helps you think about this just a little bit. The strong acid, you don't need to do anything with that. It completely dissociates. So let's look at, first of all, we have to look at how many moles of each we have. So we've got the weak base, and it is 0.025 liters, and the molarity is 0.2. I hope that's right. And that means we have 0.005 moles of the weak base. All right, we're starting out with that. And then we've got the strong acid that we're putting in. And we have, we're adding 15 milliliters to begin with, so that's 0.015 liters. And the molarity is 0.12 molarity. And remember, from my very first exam review video, I said make sure you keep that little equation in your pocket. Molarity times volume gives you moles, okay? You ought to be able to pull that up very quickly. And so you've got 0.0018 moles of the strong acid. Okay, so what we know is that even this weak base, it will mole for mole cancel out the strong acid. Okay, so let's get the BCA chart going, okay, because first we have to do the chemistry. Stoichiometry first, okay, and that means a BCA chart, and that means moles. Okay, now again, kind of the hardest thing to get for this BCA chart is what are the substances at the top. So you've got your strong acid, you're mixing it with the weak base, it's in equilibrium, and so the weak base has a conjugate and some water. Okay, so your strong acid is 0.0018 moles. The weak base is 0.005 moles. And we've got 0 here, 0 here. Okay, now the change is you've got this limiting reactant here. So this is going to go down by 0.0018, 0.0018, and this is going to go up by 0.0018. And so the strong acid is wiped out, and what you've got is 0.0032 of the weak base and 0.0018 of its conjugate acid. Okay, now we were given the KB, so that means the Henderson-Hasselbalch that we want to use is, and you don't have to use this one, POH equals PKB, and that means that we want, if this is a base and this is a base, then you want your base concentration on the bottom and your conjugate acid on top. Now remember, go back to that first video if that's not what you want to do. If you want to use pH, you can. You're going to have some more calculations though. So the PKB was given in the problem. So we want the negative log of the KB, because that's PKB, 5.2 times 10 to the minus 4. And then, oops, forgot that little word log there. Log of the conjugate acid over the weak base. Okay, now, don't forget that in Henderson-Hasselbalch, we don't use moles, we use molarity, okay? So you have to think back to the fact that you've got a total now of 40 milliliters, or 0.04 liters. And mathematically, I'm not sure if that matters, but, you know, check it out, prove it to yourself. So, whoops, what do we have there? Okay. So, you should be able to do that math, and, oops, let me get my pen back here. And you'll end up with a POH. Pause the video if you need to, so you can do this on your own. The POH is 3.03. That means the pH, which is what's being asked, is 10.97. Okay? End of part 1.